this general form mxy dx plus nxy dy is equals to 0, or dy is equals to 0, right? So here mxy is a function of x, and when we compare with 1, we have the value of mxy is nothing but 3x square y plus y power 3, right? And nxy is nothing but x power 3 plus 3xy square, right? So here one important point, you can see that the function mxy is a homogeneous function, right? Why I am saying it is a homogeneous function? So homogeneous function is one where the degree of each term is same. So here the first term have degree 3, like 2 for x square and 1 for y. Second term also have a degree 3, right? So it is a homogeneous function of degree 3. So I can say that m is a homogeneous function, and similarly n is also a homogeneous function of degree 3, right? And if both are homogeneous function, this implies given differential equation is also homogeneous equation, right? Now we need to check whether this given equation is let's check about the exact, right? Yeah. So like the condition of exact differential equation is exact ODE is that the partial derivative of m with respect to y should be equals to the partial derivative of n with respect to x, right? So here let's find out the partial derivative of m with respect to y. So it's nothing but the partial derivative with respect to y of this function 3x square y plus y power 3, right? So it is coming out to be nothing but 3x square plus 3y square. Okay. Also find out the partial derivative of n with respect to x. So it's partial derivative with respect to x of n. N is what? X power 3 plus 3xy square, right? So this partial derivative of like x power 3 is 3x square, and then 3xy square is nothing but 3y square, right? So here I can say that both are equal, hence given ODE is exact, right? So option A is correct, right? Which say it is both homogeneous and exact ordinary differential equation. Okay. So now let's move to the second question, which is question number 45. And this question belongs to the difference equation. It is not a differential equation, but this question is of first order difference equation, right? So here given to us is the value of xn is nothing but n plus 1 upon n multiply with xn minus 1, right? And this is true for all n is equals to 1, 2, 3, and so on. So my point here is, can I write down this as like this, n plus 1 upon n multiply with n upon, I would say, n minus 1 into x times n minus 2, right? Because by using the same equation, let's say this is equation number 1, if we replace n by n minus 1, right? So we have x n minus 1 is nothing but n minus 1 plus 1 upon n minus 1 into x minus n minus 2, right? Which is nothing but n upon n minus 1 x n minus 2. And this follow the same pattern. So this will become the next term here will be n plus 1 upon n into n upon n minus 1, and the next will be n minus 1 upon n minus 2, and this will become x n minus 3, right? So continue in the same way. I can say that I have xn is nothing but let me write it into the form of product. So t is equals to 1 to n t plus 1 upon t, right? And this product multiply with x naught. Make sense? Right? It's nothing but the continuation, right? So this product is like n plus 1 upon n into n upon n minus 1. We can keep putting the value of t and everything like in form of product. Okay, here in this question, given that x naught is nothing but 2, right? So if x naught is nothing but 2, this implies xn is twice of this multiplication, right? T is equals to 1 to n, t plus 1 upon, sorry, t. Okay, now, now how this product will look like, this is important here, right? So as you can see that this product is, so let me write it, t is equals to 1 to n. So like t plus 1 upon t. So for n is equals to 1, this is nothing but 2 by 1, right? Next term is nothing but 3 by 2. Next term is nothing but 4 by 3. And continuing in the same manner, the last term we have is n plus 1 upon n, right? So we can cancel out. And in last, we have nothing but n plus 1 remain, right? So using this, we can say that we have xn is nothing but twice of 1 plus n for all n, right? Now, so using 2, we can find out the value of x100. It is nothing but twice of 1 plus 100 and it is like 202. Agree? Similarly, the value of x50 is nothing but twice of 1 plus 50, right? So this is 102. They ask for the difference, therefore x100 minus x50 is nothing but 202 minus 102, which is nothing but 100, right? So 100 is the answer here. Okay, now let's move to the next question, which is like last question for this video. In the differential equation, they ask three questions, like including both differential equation and difference equation, right? So this is question number 54 of JAM Economics 2021, and this question of first order differential equation, right? So if you can see that the given differential equation is dy over dx is nothing plus y is equals to y square, right? So I can write down this equation as dy over dx is nothing but y square minus y, right? Which is nothing but y upon, oh sorry, y multiply with y minus 1. So this is variable separable equation, right? Because like the side is function of only one variable, that is y here. This is variable separable equation. So this can be rewritten as dy divided by y times y minus 1 is nothing but dx on other side, right? Or this can be written as dy, so let me write it into the opposite direction. So it is nothing but 1 upon, let me see the symbol as well, 1 upon y minus 1, right? So it should be minus 1 upon y plus 1 upon y minus 1, correct? Yeah. Into dy is nothing but dx, right? So integrating both side, taking integration on both side. So when we integrate both sides, we have minus of ln y plus ln y minus 1 is nothing but x plus, say, constant at c. So this can be written as logarithm of y minus 1 upon y is nothing but x plus c. And this can be further rewritten as y minus 1 upon y is equals to c1 into exponential of x, right? Where c1 is nothing but e power c. Again, constant. So I can write it down in this format, right? Now, using the condition, they give us like y of ln2 is equals to 1 by 3, right? So this imply we can have here like 1 upon 3 minus 1 divided by 1 upon 3 is equals to nothing but c1 e power ln2, right? Or this can be written as, see, 1 upon 3 minus 1 is nothing but minus 2 by 3. This is 1 by 3. So I can say that this is minus 2 is equals to twice of c1. Or c1 is nothing but minus 1. Make sense? This imply we have y minus 1 upon y is nothing but minus of exponential x. Or this can be written as y minus 1 is nothing but minus of y e power x. Or this can be written as y is nothing but 1 upon 1 plus e power x, right? It's a simple calculation. We can have like minus y e power x on other side, so it become y plus y e power x, and 1 on other side, so it simply become 1, right? Now, they ask us the value of when x is equals to ln 3 or e power x is nothing but 3. Therefore, the value of y at ln 3 is nothing but 1 upon 1 plus 3, which is 1 upon 4, and the value become nothing but 0.25, right? So this is our correct answer. So that's all